So today we'll be talking about pass by value and pass by reference. And we are going to use this to finish our discussion about JavaScript types. So I think hopefully this weekend we should be able to be done with advanced JavaScript. So we can move on to something else. We can learn some commands. We can learn how to what Git and GitHub is and everything. Then once we are done with that, we can move on to the advanced web development aspect, which is using React and also building the backend of software applications. So can you see my screen? Hello, can somebody see my screen? Hello?
Yes.
Okay. So thank you for that. I don't know, maybe the network is kind of bad, but then, so let me share my whole window. Okay. So back to today's topic. Like I said in previous lessons, primitive values in JavaScript are, they are aptly named, and we have let's say 5 of them. Is it 5? We have 6. So they are the most basic values one can think of, which includes undefined, null, boolean, string, and let me just write them out. Primitive types. So we have primitive types. We have the undefined. Oops. We have undefined. Then we have the null. Then we have boolean. We have strings, which you remember. We have numbers, and we have the other one, symbols. Okay, fine. So these are 6. So primitive types they are the most basic values one can think of, when it comes to JavaScript. So primitive values are passed by value, or primitive types are passed by value, which is the first part we are going to we are going to dive into today. So in the previous sections, I said that primitive types are immutable. And what does that mean? It means that we can't really change them. In order to change them, we need to completely remove the primitive type. And let's say we have something like, should I leave this here? I will still need to comment them out so that I won't get error in my console. I know some people will be like, Ridwan, what is this environment again? This is we call it repl.it. So it's just like online coding, online code editor. Sorry to say that. So instead of me using my, what's it called, VSC, then trying to shovel between the VSC and the browser's console. So I can just, I have access to both here. So I have something here. So if I do console.log here, so I can get it. So it's just an environment. So nothing too serious. So if I write read one here and I click run, so read one is going to get printed here. You see that? So it's just like I have my code editor here by the left hand side. Then I have my console here. So nothing too serious. I just think we can use another environment instead of our normal what was it called, VSC and browser console. So these are one of those things you would want to be using as a developer. So back to our class. What do you mean by primitive types? By saying they are immutable. So it means that we can't really change them. But in order to change them, we have to completely remove the primitive type. So for example, let's say we have let a equals 5. So 5 is a number, and a number is a primitive type. So in order to change what the value 5 is, I have to literally I have to literally remove it from memory and create something like, probably something like a equals 10. So I can't really modify what 5 is. And like I said the other time, I said 5 is the same in Nigeria, 5 is the same anywhere in the world. So you can't change that because 5 is 5. So you can't modify it. So it's just something that's, it's something that is getting created every time. And, that is just what primitive types are. So when I assign 5 to A, somewhere in memory, variable A is going to contain and reference the value 5. So if I do something like console.log 5, console.log A, so if I press run now, you see that A is going to get logged here, and A is what? A is 5. So let me just label that so that we'll see. It's something with A is okay. So it's something that we've actually been doing and we are used to now. So if I do something like let's b equals 10. So now I have two variables. So let me just delete this now. So I have two variables in memory. So I have A, which has a value of 5, and I have B, which has a value of 10. So these two variables in memory, they don't know each other. They don't know that A doesn't know that B exists, and B doesn't know that A exists. They are just in memory. They are just on their own. So this is what we call pass by value. So let me just pass by value in JavaScript. So this is what it's called, pass by value. So the easiest way to think about pass by value is that it is making a copy of the original. So if I do, what can I do here? A plus 5 here, or let me say A plus 35. So if I console.log this out, console.log A plus 35. So if I console.log this out, A plus 35 equals 5. So that means this A equals 5. So this value 5 is passed to this. So it's going to change it to something like 5 plus 35. So that is what pass by value is. So this means that two of the exact same things are being made. So if you go to change the copy, it doesn't change the original. So that is pass by value. But objects on the other hand are what we call them pass by reference. Pass by reference, not just objects and arrays. But I'll show you what all this, what they mean. So I think the best thing we can do is just to write some code so that you understand what is happening here and what is happening by, under pass by reference. So, over here we have, let me just copy this to make it on the same. Okay. So over here we have let A equals 5 and let B equals 10. So variable A now has an address of where this primitive value 5 sits in memory. Same with variable B. B has an address of where the primitive value 10 sits in memory. So what if I do something like, instead of B equals 10, what if I do something like B equals A? What happens? Remember that primitive types are passed by value. So if I do let B equals A, if I console.log, let's see what we have in console.log B. So if I console.log B now, let's see what we have. So we have B equals 5. So then you know that A equals 5, we assign this 5 to the variable A. So we are saying that, whenever people are talking about A inside this code and it is of, the same scope, then A should be equals 5 until we reassign another value to it. So anywhere in my code that I have A in the same scope, it's going to be 5. So now we are now saying that, okay, we have another variable B. So this variable B should do what? Should pass the value of variable A and store it. So that is what we have. That is what pass by value is saying. So, okay, what if I do something like, let's do B++. By now we know what B++ means. So B++ means what? It means B plus 1. So B plus 1 is what? It's going to, like, okay, you say B plus 1. Then what is B? What is B? So it's going to check B. B is A. Then it's going to check what is A. A is 5. So definitely B is what? 5. So 5 plus plus is what? 6. So that is what we meant by pass by value. So if I do B plus plus and I do console.log A, and let's see, what do I get? I get 5. So what if I do console.log B? So let's say, let's give it a label, a label or a name. B is B, and let's say A is A. So if I console.log this, let's see what we have. So we have A is 5 and B is what? B is 6. So which is B plus plus. So we have 6. So, and that is because of pass by value. So all what JavaScript ng did was, copy the primitive value of 5 as if, 5 equals, as if B equals 5. So it copies it here. So just like this. So then B now reference to the value of the primitive value 5 here. We have primitive 5 here. So it's just like copying whatever value we have here. So that is that. And if we look at, I have a diagram for us here. If we look at this diagram here, we'll be able to like understand, and I think this should make sense. So even though that we did B equals A, we simply copied the value from A and put it into a new memory space in our machine with B. So we just simply made a copy. They don't really have any connection whatsoever. And that is what pass by value is. Pass by value simply means that we copy the value and we create that value somewhere else in memory. So it's just like you are making a duplicate of something. Like, okay, fine, I already have one item here, but then I want to copy that item from location A to location B. So the more you copy that item, the more space you consume in memory. So you are consuming a lot of memory. So that is what pass by value means. So back to, so this equals operator, this equal sign operator, it plays a huge role in how pass by value and pass by reference work. When creating a variable, this equal sign, this equal operator will notice that you are assigning that variable a primitive value, or probably an object, and act accordingly. So let's see, we've talked about pass by value. Let's see how objects are different, unlike what we have here. So let's say I'm just going to delete this. So let's say I want to create, let me move this up a little bit. So let's say I want to create an object. So if I create an object like, okay, sorry, let's do this. So if I create an object, like if I do like this. So if I do let obj1 equals, let's say I want to create an object like name, read1, And let's say read one, the object has a password. So it has, what's it called? A username and a password. So let me create another object now, just to explain what pass by reference is, and you actually see the difference. So if I say let object 2 equals object 1, just like we did with let b equals a, and so that, you know, object 2 and object 1, you know, we are just trying to like make them the same, just like we did with a and b over here. So what if I go ahead and do, you know, object 2 dot password? What do you think is going to happen? And I set another password to it instead of that 1, 2, 3. So let's say the password now, the new password is secret. What do you think will happen? Because if you remember, I told us like primitive types like 5, they are immutable. That means you can't change them. And if you remember in our previous sections, I told us like primitive values in JavaScript are values that are determined by the JavaScript programmer. As in those people that actually wrote JavaScript, they determine what these primitive values are. You can't change them. But then we have the object that you can change. So they are non-primitive because you can change them and you can do whatever thing you want to do with them. They are not, what's it called? You know, you can change them. So here we have primitive values and here we have an object. So if I do my first object equals this value, then my second object is going to equal to first object. Then here I am changing the password of second object. So what do you think is going to happen? You know, let's see what's going to happen. So if I console.log obj1 here and console.log obj2, so if I run this, let's see what's going to happen. Wow, you see that the password has changed for both. Okay, let's comment it so that we'll know which one is coming out. So if I do obj2 here too, and we have a comma here, so I'm going to rerun this. So we see that the password has changed for both. So I think that is having an issue. So let me just leave it the way it was before. So if okay, I have it now. So you see that the password has changed for both. It has updated for both objects. So by doing this, we are passing by reference. So if we go back to the slide that I have over here, you see that objects in JavaScript are stored in memory and are passed by reference, which means that we don't copy the values like we did with primitive types. So instead, we assigned object 1, you know, to this. So we assigned object 1 to object 2. We are simply saying that, hey, this is where the object is in memory. So reference it. So if you go back to, let's go back to our code. Here we see that object 1 and object 2 are pointing to the same location somewhere in the memory. We actually don't know where, but somewhere in the memory, if you know, they contain the same object information. So all I did by saying object 2 equals object 1 is just like I'm saying, hey, you know what, object 2, this is the address in memory of wherever this object 1 information is located, and this is the information. So I am referencing that. So here, literally I'm saying address in memory. So object 2 equals address of object 1 in memory. So I'm just referencing that. So when I change the password, I'm saying that change password on this object in memory that object one is also pointing to, or that object one is referencing to. So that is where pass by reference comes from. So in pass by reference, instead of making a copy of the original value, like we did with pass by value, you are making a reference to the original value. You are not making duplicates. So a change made on the reference is actually changing the original information. So no new location or object in memory was created. Rather, both variables are pointing to the same location in memory, just like you see here. In primitive type, once you are creating duplicates in primitive types, so that is passed by value. You are passing the value, you are duplicating the value. But in pass by reference, you are not duplicating, you are referencing to that. You are referencing to a particular location in memory. So you are not creating duplicates. It's just like you are referencing that, like, okay, fine, read one. If you want to do this, you go here. Instead of saying, okay, read one, if you want to eat, you create your own kitchen. No, you are saying, read one, if you want to like eat, you can go to my kitchen, then you can have access to whatever I have in the kitchen. You can remove something from the refrigerator. You can put something there. You can change anything in my kitchen. But by pass by value, I'm saying, read one, you know what? If you need something, you can copy me. You can copy my kitchen style. But then you have to have your own kitchen. So imagine you have a house and we have like 10 occupants in that house. So imagine each occupant are creating their own kitchen. So that means they are going to eat up a lot of space in that compound. And imagine we have pass by reference, like we have just one kitchen, then, I'm referencing that, like, okay, fine. If you want to take something, then you can reference to that kitchen and take whatever you want from that kitchen. For example, I have another slide there, oops, this is to like display, but I don't know why it's a GIF. Wow, that's serious. So I actually have, maybe I will play somewhere else. So by pass by value, I am making the total duplicate of this here. But by pass by reference, once I reference this cup here, whatever I do to this cup is going to get applied to this particular cup too. So the question now is, why is pass by reference a good idea? Let's think about it. Like, why is this good? I mean, it's kind of nice. Like, you don't have to create a lot of things. You just have to like, reference somewhere. Why is it good? It's kind of nice and it's good. And the reason is because by just having one object here, we are saving space and memory. So we are not copying, we are not cloning, we are not duplicating the objects. We are creating multiple versions of it. So we can simply save memory by referencing just one location instead of making duplicates and just loading up your memory heap. So the reason why this might also be bad is because unlike primitive type, we might have this issue where by mistake somebody else can change something on this, on that referenced object. For example, like here we have a large kitchen in the compound and somebody else has access to that. But it is possible that they can come here and change something without my, without my knowledge, and I might not know, which might create a lot of problems. Imagine I have a naked wire somewhere, and I know that, okay, I'm putting this naked wire, though it is not safe. We don't do naked wires. I'm just using it as an example. So imagine I put the naked wire there, like, okay, fine, I need to like do something to that, and I just have to go out and buy something. Just like maybe sellotape or something just to cover it up. And someone else have access to my kitchen and they put that naked wire by the doorstep. So they are changing some things which sometimes might not be good. And this is where this might be good. whereby everybody has their own kitchen. Whatever you like, you can do it. You are just copying my style. Like, okay, Ridwan has a kitchen, and inside his kitchen, he has 5 bowls, he has 3 cups of rice and everything, and you duplicate that into your own kitchen too. So whatever you do in your kitchen, I don't know. I don't care. It's your kitchen. So that is where this is actually useful. So the reason why this might, also be bad, like on like a primitive type, this pass by reference, we might have issues whereby somebody might make a mistake, probably by changing the property on that reference object. So this is something we actually need to like be very careful with. So let's just go back into our code and let's do another example. And like I think in the previous sections, I told us like arrays are just objects. They are simply objects. Arrays, they are simply objects, which have shown us like, the reasons why they are objects. So let's also do this pass by reference and let's try it on arrays. So let's say, let me just delete this. So let's say I have a variable C, and inside this C, I have a list of numbers like 1, 2, 3, 4, 5. And I have another variable, which is D, and D is referencing C. So which means whatever I have in D is in C. So let's just console the log both out and let's see what we have. So here, let me say C, and we have C, and here we have console the log D, and we have B. Oops. B, we have D. So if I run this now, we can see that we have in C we have 1, 2, 3 arrays of an array of 1, 2, 3, 4, 5. So in D2, we have an array of 1, 2, 3, 4, 5. Fine, that is cool. What if we do something like, let's push to D. So let's say we want to push some values to D. Let's say we have 3, 6, 4, 6. So if I push this to D, what's going to happen? Let's see. You see that this is referencing the original object. So whatever action I perform on D, I'm pushing to D now, is getting applied to C. I don't know if we actually understand this. So we are modifying the original array. And because arrays are objects, they are also passed by reference. So variable C should also have, whatever variable D has, whatever changes we made on variable D is going to get applied on variable C too. So that is what passed by references, and this is actually good because we are saving memory. So we are not just constantly copying things, and duplicating things and eating up memory. So we are saving the memory. So imagine C was a massive array, like a very large array of things, and we want to like, if we try to copy that, it means we are heating up the memory. So if we are copying this massive array, imagine it's a massive array. If we are copying this massive array to different parts of the code every time that we need it, this is going to create a lot of memory. It's going to eat up a lot of memory. But then there are times where probably maybe we do want to own an object. We want to have a duplicate copy of it. We want to copy the object instead of referencing it. So, so that we can modify that particular object without affecting the original object. So how can we do that? If you remember, I said like, I think it was during when we started the arrays, when I was showing us some array methods, I showed us one particular method, which is concat. And I told us it's concatenation. And what it does is it copies the original array, then concatenates another array to that to create a new array. So you have the original array, then you have the new array without modifying what the original array is. So just like arrays, there are different ways of copying, an array and modifying the array without affecting the original array. For example, let me just delete this. For example, let's say I have this. So instead of doing dot push, I can do something like inside. I have an array stored inside variable C. Then I want to have another variable D, which is going to like copy this array, but then I want it to stand on its own. So what do? You do empty array dot concat. So if I do dot concat, then I'm going to pass it whatever I want to concatenate, which is C. So if I do this now, I am copying C into this. I am concatenating array C, with empty array, then I'm saving it inside D. So whatever I have inside this concat is going to get pushed to whatever, arrays are empty arrays that I have here, or probably a list of other arrays. So let's check what we have now. So if I do console.log, let me just give it a label so that we know what we have. This, let me write, this is array C. Then let's check what we have in C. Then I can say console.log, this is array D, and we get D. So if I run this now, we see that we have the same arrays, which is cool. So I'm just cloning the original array into D. So objects are, cloning objects or copying or making a copy of objects are a little bit more difficult. So let's see what that means. Let's say I have an object here. Let's say we have obj, which stands for object, and we have an object of property A with value A, property B with value B, and property C with value, property C with value C. So let's just close that bracket. So I want to have this object information in a different location in memory. How can I do this? If I want to have a different, I want to clone this into a different location in memory. If I do it like let obj2 equals obj, it means I'm still referencing this, but then I want this to stand on its own. So if I do it like this, it's going to like pass by reference, and we are still going to be referencing the same object here. Instead, we can clone an object by doing something like this. So let me just change this. Let's say we want to clone. So let me give it a name, obj clone. So if I want to clone, I do object.assign. Object.assign. So inside this .assign method, the first parameter is the object to copy to, and that is going to be an empty object. So that's going to be the first parameter, and the second parameter is the source from which to copy the properties from, which is the object that we have above. So now let me console.log both out so that we can see what we have. Let me just comment this out. Then, so if I do, this is first object. Let's do first object. So we have objects, and this is cloned objects. And here we have obj cloned. So let's run it and see what we have. you see that I actually cloned the first object. So they are having the same properties and value. So if I change anything in this cloned object, it's not going to affect the original object. So let's say I do something like, we have obj, which is the first object, dot c, and I'm changing the value of c from, instead of c, I'm changing it to 5. So if I change this to 5 now and I run it, you see that c changed to 5, but the cloned object doesn't change because we are not referencing, we are not doing pass by reference. I have cloned it and they are on different location in memory. So the cloned object is not affected at all when I did this, even though I changed the value of c to 5. Remember, if we didn't clone the object, if we do something like, let's say I do something like, let's what English can I use? Uncloned. Don't mind me if there's something like that. Let's uncloned object equals obj. So if I do something like this and I do obj dot c equals 5, if I run this, okay, let's just console.log that out too. So this is uncloned object, and it's going to be uncloned object. So if I console.log this out, let's see what we get. You see that the first object is this. The uncloned object that we did pass by reference to, whenever I change the first object, whenever I change any value or any property inside the first object, is also going to affect this cloned object like we have here. You can see that the c changed to 5, but we are making a copy of this object clone. So whatever I do here is not going to affect it because we are creating a different location for it in memory. So that is what pass by reference is all about. There is another way of doing it, like if you want to clone an object, and to me, it's the easiest way. Instead of, I know you are confused, like, Ridwan, what is the meaning of this object dot assign, blah, 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 this looks so weird, and it's something like I might not be able to really understand for the first time. But then, there is another way of doing the cloning of objects in JavaScript, and that is using the spread operator. So we can do something like this. So let me just spread operator. So how do we do that? If I want to clone, I can do let obj clone 2, which is the second clone. So I can do empty object, then copy, use 3 dots, copy whatever I have in the first object. So if I console.log this now, so let me just copy and modify this. This is spread, let me do spread operator clone, and I do object clone 2. So if I run this now, still running my network. Do we have, sorry, that's still running. I think I have to go back to my, what's it? Okay. So we have that. This is spread operator cloned. You see that it's cloned the original object. So how do you do that? You do the variable, then 3 dots. We call this spread operator. So it's going to spread whatever we have here inside here. So you can also do the same thing for arrays too. So if I want to clone this array C, instead of doing concat, blah, 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 I can just do let C2 equals spread whatever I have in C. So if I console.log this now, so let's just console.log that and let's see what we have. So if I console.log, this is clone RFC2. Oops. I do C2 here. So if I console.log this out, you see that it's going to like copy this. You see it, this is it. It copied it. So we call that spread operator in JavaScript. It is so easy, so straightforward, you know, it makes life beautiful. So I'm just going to comment this out. I just want to show us that. So this spread operator is very nice and it's very clean. And it's also a new feature that we got in JavaScript language, which is really, really nice. And, you know, it doesn't modify the original object if you change anything here. So that is that. Then the question you might have in mind is, what is the significance of pass by value and pass by reference? The significance here is memory. You know, every variable is stored in memory. If we do, let's see, C is stored in memory with whatever value you pass to it. The same thing with this obj2, the same thing with this, you know, obj clone and everything. Every variable is stored in memory and allotted a specific amount of memory. So larger data types like objects, like arrays, they require more memory. So in pass by reference, JavaScript is attempting to save memory space by passing an address in memory, aka reference, of where your data is, instead of allotting additional space in memory to make a separate copy of your data. So cloning is a great thing to do like this, but you know, it's a question like you might ask yourself, what do you think will happen if we have an object inside an object, like a nested object? You know, for example, let's say we have, let's say inside this, let me just delete all these, what's it called? Oh, let me leave it. So let's say inside this object, and this property C, instead of just being a string, let's say it's another object. So it's another pass by reference object that has a deep, let's say C, then it's going to be an object and it has a deep, then let's say a string here, try and copy me. Try and copy me. So this is an object inside an object, like a nested object. And it is also possible that in here, you can still have another object. So like, let's say this also is going to be like deeper, and it's also going to have another object, which is deepest. And here we can say, I am the deepest. You can go, you know, deeper than this, but I'm just like showing us like this is just like, what can I say? Let me uncomment this. So we call this let me run it first. Let's see what we have. Oops. Okay, we are still changing this. So you see that now. That is why this is one of the reasons why you wouldn't want to do something like this. I forgot, like I've changed something here and it's like affecting my code. So you see this, we have a deepest, you know, objects nested inside of each other. So let me just go back to the highest level so that, you know, life is not too deep. So that we can have something like this. So what happens here? We have an object that is referenced somewhere in memory, and inside that object, there is another object or there is another pointer to another place in memory that references this object C. So if I run this code now, the way it is, you see that nothing has changed. What I have here is just the original object and the C getting changed. Then we have the cloned object. So nothing has really changed than what we've actually seen before. So what if I do something like this? Object.c.deep equals, let's do this. I can't copy you, but I can change you. What if we do something like this? Let's run the code. Oh boy, what just happened? We can see that, we cloned everything, but it got overwritten. What is happening here? Remember, each object gets passed by reference. Although we cloned here and here, we cloned the initial objects, and this is what we call shallow cloning. So shallow cloning is just like it clones the first level, that is the memory address of this parent object. But within this parent object, there is another address to another object. And this address of the nested object never changed. So it always referenced this object. So this is a shallow cloning that we did here. And the way we can do this is, a little bit funky. So we can use something called JSON. So we can just say, like, let's say let deep cloning, or let deep cloned object equals JSON dot parse. Dot parse. Actually, this is beyond the scope of the of this present level of of the course of the training. But don't worry, we are going to get to this when we get to the backend section. You can actually read up on what JSON is and what JSON.parse is. But this JSON object is just going to say, like, you know what, I want to copy this thing. I want to, like, do some operations with it. So don't worry too much about this. I just want to show us. So when we get to the backend section, whereby we'll be like, passing data and the likes, you are going to see what this JSON is all about. So this JSON object is going to say, JSON.stringify, then the object we want to say stringify. So here we are going to stringify. That is, we are going to turn everything in this object into a string. Then once we turn everything into a string, we are going to pass it and turn everything back into an object. So that if I do something like, let me do console.log deep clone. This is deep cloned object. So if I do this deep cloned object, so if I run this now, let's see what we get. Let me paste this to the, so coming. Okay. So deep clone actually did a deep clone of the objects. So I'm just going to deep clone the object, then convert it back to what we have here. Oops. I have too much instead of log. So before we end this section, I hope pass by reference and pass by value actually makes sense to you. You know, and I do want to give you a bit of warning. However, if you are doing a deep clone, you should be very, very careful because this can have some performance implications. So if this object is extremely deep, like let's say we have a deeply nested object, you know, it's going to take a long time to clone everything. So you won't see this out in the wild too much. You hardly see it. So if you are cloning object like this, there are most likely, you know, probably some other ways that you should be doing this actually, aside from the one I've shown us, like using object.assign and using the spread operator. But I just wanted to show you the idea of pass by reference, the idea of shallow cloning, deep cloning, and some of the ways that we can use objects to get the desired result. So I hope that was fun, and we can move on to the next section, which is very, very interesting. So let me just stop this video here then.